everyone, hope you're doing fantastic. This is a tutorial video that's going to be doing a deep dive into BOOM DAO's products and how to use them. Right now I'm going to give a brief overview of the products and also a little intro as to why they were created and what their purpose is. So if you want to skip kind of that part of it, you can skip to later in the video where I'll be going through all the products step by step and teaching you how to use them. So to give a brief overview of the products that BOOM DAO has built, there's essentially three main products. We have the game launcher, the Unity template, and the World Engine protocol. But actually I want to focus most of this tutorial on the World Engine protocol. And this is the one that I'm the most excited about, and it's what I want to share with you a bit today, why we built this protocol. So if you follow the Ethereum ecosystem, you may have heard this concept called an autonomous world. And basically what an autonomous world is when you put all the logic and data of a world or a game fully on the blockchain. And as it exists fully in smart contracts on the blockchain, it means that this is a transparent and composable world that anyone can plug into, extend, modify, and build on top of. And essentially what the World Engine protocol does is take this concept and supercharge it with the abilities of the internet computer to store all the state and logic of a game on chain and allow for new possibilities for extending and modding your favorite games. So let's start with a more concrete example of this in practice. Let's say you have your favorite game. It could be Fortnite, Call of Duty, World of Warcraft. Basically, those games are hosted on infrastructure around the world, things such as Amazon Web Services, Google Cloud, Microsoft Azure are basically the backbone providing the game servers and the databases that store the data for all these games. And so if the game developers decided, hey, you know what, we don't want to support Fortnite anymore, let's close it down. That leaves you unable to play the game anymore. It leaves your user data deleted and gone forever, and all your progress is essentially kaput. What this problem creates is, a lot of games that eventually die off because their user bases can't access the game anymore. And so this concept of autonomous worlds essentially prevents any of this from happening because it takes the concept of a game and puts it entirely on the blockchain where it can exist forever and ever. And so nobody can ever take it down, nobody could ever censor it. And the infrastructure, since it lives fully in smart contracts, is open, permissionable, transparent, and anyone in the world could take those smart contracts, copy them, duplicate them, deploy their own worlds, deploy their own games, modify the current games, and extend the games that they love the most. If you loved, playing World of Warcraft, you could essentially build smart contracts on top of the World of Warcraft smart contracts and extend the game with new gameplay, with new game modes. And since these digital worlds are permanently existing on the blockchain, this essentially allows players to become creators in their favorite digital worlds. So you can imagine a game developer deploying, let's call, a base world. And then on top of that, players are building their own versions of their worlds on top of this base world. And so this world is constantly evolving and changing as players and creators are adding to it and building their own metagames on top of it. And so the community that loves playing this game and loves developing it can continue to develop this digital world, this digital nation, you could call it, for the rest of eternity. And so that's something that we're really excited about, and it's the reason why we built the World Engine protocol. So if you're a game developer, then buckle in because we are about to go over step by step how to build a fully on-chain game in a matter of hours. All right, so let's talk a little bit about the World Engine protocol. The World Engine protocol is essentially a protocol that acts as a database for all the games on the IC. And so when you deploy a world in the World Engine protocol, that world is essentially your game server. And so rather than using a game server on AWS or Google Cloud, your game server is going to be deployed as a canister smart contract. And we call those a world. And so all these worlds of all these different games are connecting to the World Engine protocol, which is storing all of their data in canister databases and allows all that data to be interoperable and composable with all the other worlds that are connected to the protocol. And so how do you deploy a world for your game? So if you want to deploy the world backend for your game, there's two ways to do it. You can do it from the game launcher, which is the recommended way, and it's really, really easy. Or if you want more manual control, you can go to our GitHub and you'll see that there's a world template repo in the BOOM DAO GitHub. And basically you can download the world template code, which is written in Motoko, and customize it, rewrite it. Basically a world can be written however you want, but it has to connect to the World Engine protocol in order to store its data. So this also allows you to add custom functionality in the form of plugins, which is something that we can talk about in a little bit. But if you want to add, custom functionality, custom code to your world, then maybe it might make sense to deploy your own world. But for the sake of this tutorial, I'm going to show you guys how to do it with the game launcher, since this is what we recommend and it's the easiest way to do it. So you go to the Deploy Worlds tab, and you'll see here that you can see the worlds that you've created, or you can see everyone else's worlds. So these are all different worlds that people have created. And you also see, actually, I didn't mention this before, but you can actually see all the collections, NFT collections and token collections that other people have created as well, just by going to the Everyone's Collections and Everyone's Tokens tabs. I'll create a new world just for the sake of it. We can call this world Earth World. I know that's super original. Awesome. So now we have Ocean World, Cloud World, and Earth World. And so, I used the same image, so that's a bit confusing, but we'll roll with it. So once you've created your world, you can click on it, and you can see you have a few options here. You can set the admin's controllers of your world, you can import world data, or you can configure your world. We'll talk about importing world data in a second, but essentially we can talk about it right now. So importing world data basically means that you can import all the user data of another world into your world. And you can also import all the configurations of another world, like all the rules of that world, into your world as well. And so basically this allows worlds to be entirely duplicated, and then for you to extend or mod another person's world. And this is really the key aspect of worlds that enables, new functionality for creating new experiences that are built on top of a base layer world. And so we'll dive a bit into how to do that later. But here at the first tab, you'll see that we have this configure world tab here, and we can go ahead and click on it. And we have to log in with our NFID to authenticate the ability to call this world. So we're going to log in, make sure to log in with the same account that you logged into the game launcher with. So it has to use the same NFID identity to make calls to this world. And you'll see here, once you've logged in, there's this custom candid UI that we've created. And this allows you to basically configure your world. So in a world, there's all these different functions, and basically like a world can be broken down into two things. There's actions and there's entities. So actions are essentially the rules of your world. So you can think with any game backend, the game backend has to validate everything that the player is doing to ensure that the player is not cheating. And then the game backend also regulates the game economy. So, if the player spends 100 gold, the game backend validates that it costs 100 gold to get one sword. And so it checks to make sure the player has 100 gold, deducts 100 gold from the player's data, and then gives them one sword in the player data, right? So basically all of these validations and changes to the database are essentially all done through actions. And actions are entirely configurable from this candid UI. And then you also see there's entities. So entities are basically all the things in your world. So these include items, buffs, achievements, stats, characters, really anything that's an object in your world can be represented as an entity. And entities are essentially the smallest unit of data that's being stored in your world. So what I'm going to do is go over each of the functions in a world and kind of talk a little bit about each of them. So first we have these create action config and create entity config functions, and these are the ones you're going to use to create the actions and entities that players are going to interact with in your world. Down below we have delete action config, delete entity config, which are basically deleting any configs that you created that you want to delete. And then you have get action configs, which if we query right now, you'll see it's empty because we haven't created any action configs. And then you'll see that we also have get all user world actions. And basically, when you do an action in a game, it's going to store data about that action in the world. And so if there's any action that a player has done, this will return any of the data about that action in that world. but since we don't have any actions that we've done in this world, there won't be, any data for this yet. And same thing for get all user world entities. We haven't created any entities in this world yet, so there won't be any entities when we call this. And then when you call get entity configs, it'll also be empty because we haven't created any entity configs for this world. And then you'll see here we have some functions for the permissions of a world. And we haven't really talked about this much, but essentially you can create permissions on your world to allow other worlds to change certain entities in your world. And so this is where, composability comes into play, because you can have, one world where let's say it's a game like Utopia and you have gold in this world, and you have another game like Plethora that has, you're doing races in Plethora. And let's say you want to be able to do a race in Plethora, and if you finish the race, you get some gold in Cubetopia. So in order to do this, Cubetopia needs to give permission to Plethora to change the gold entity in Cubetopia. And so basically by calling these grant entity permission functions, you can allow other worlds to change entities in your world. And if you scroll down here, this is the most important function that you'll be using. And actually, you won't be calling it from the Candid UI, but you'll be calling it from the Unity client. And this process action function is basically when a player does any action in a game that has to change the state of the user's data in the database. So anytime the player, takes some sort of action where they get an item or finish a race or kill a monster, whatever it might be, where there needs to be data saved and that data needs to be validated, that's basically when you call process action, when the player does an action in your game. And you can see there's a bunch of different arguments that you can pass into process action. Most of the time you'll use default, where you just specify the action ID of the action that you're doing. But there's also some custom actions that require additional arguments, and that's why all these other different types of process action exist. But we'll kind of come back to that later. You can remove any permissions that you've created for other worlds to change entities in your world. One thing I kind of didn't talk about is that there's entity permissions and there's global permissions. So entity permissions is if you want to give permission to another world to change a specific entity in your world. Global permission is when you want to let another world change all the entities in your world. So they have full permission to change any of the items or stats or achievements or whatever entity you have in your world. That's if you have a global permission allowing them to do so. We have this update action config function and update entity config function. And these are basically functions. If you've already created an action config or an entity config in your world, these are ways to edit the existing action or entity configs by calling these functions. So I believe that's it. So we'll go back up to the top here and we'll go ahead and create an action. So we'll create an action called quest01. That'll be the action ID. So AID stands for action ID of that action. We're going to give it a tag, and a tag is basically some way for you to uniquely identify this action. So if you want to like categorize it somehow, I'm going to put it in the category of quests. That way I know, like, if I'm fetching all the quests of a game, I'm able to, basically sort them by tag to know, these are all the quests that are available. We have this action constraint value, and you'll notice when there's a check mark next to a parameter, that means that it's an optional value. So that means that you don't have to use it if you don't want to use it, so it's optional. So we're going to specify an action constraint, and basically what action constraints are if you have some sort of validation that needs to be done in order for this action to be allowed. So there's two types of constraints currently. There's entity constraints and there's time constraints. Entity constraints are if you want to specify that the player must have a certain amount of an entity or a certain type of entity or an entity that's not expired. There's many different parameters, but basically you want to validate that they have this specific entity before doing a certain action. So an example of using this would be if, let's say, you wanted to validate that the player has at least 100 gold before they're able to purchase a sword. So in this entity constraint, you would specify the gold entity, and you specify that it must be greater than or equal to 100 gold and then that way they're allowed to do this action. We'll kind of dive deeper into that a bit later, but for now we're gonna skip over action, or sorry, we're gonna skip over entity constraint. We're gonna talk a bit about time constraint now. So time constraint is the other type of constraint, and that is basically if you have an action that you want to be done, once every certain time interval. So, like if you have a game where you're allowed to mine resources every hour, or you're allowed to do a race every 2 hours, or monsters spawn in your world every 30 minutes. Basically, these are all actions that must be validated using time, right? And so that stops players from cheating and doing these actions over and over and over. But instead, now they must conform to whatever interval that you set for how often they can take this action. So for this quest, for example, we're going to set the action interval. I think this is about a minute. So you have to specify this in nanoseconds. So I think this is about a minute in nanoseconds. And we're going to say that you can only do this quest, let's say, once per minute. We could also specify twice per minute, 3 times per minute. We could even increase this to an hour or a day. And then, we could specify you can do this action 4 times a day. So there's many different ways to configure this. But for now, we're going to do this action is allowed once every minute. And yeah, remember this is specified in nanoseconds. So it's a nanosecond interval duration. And then you'll see here we have name, which is an optional value if you want to specify a name for this action, or a description, or an image URL if you have like an image that you want to show for this action. But those are all optional values. You only really need them if you're showing this, like if you had this quest being shown in the game and you had like an image for the quest and a description of the quest and a title for it, then these values could be used for those things. And then you'll see here we have this action result. And action results are basically, if you do this action, what do you get as the outcome of that action? And so you'll see here you have this outcomes field that is, it can have multiple outcomes. And so the reason that we do it this way is that we wanted to create, the ability to have random outcomes. So similar to how you have like a loot box or a gacha, as referred to in traditional gaming, this is essentially the ability to specify many different outcomes for taking an action. Like if you do this quest, you might get a sword, you might get a gem, you might get a potion, as a result of doing this quest. And then you're able to specify how likely it is to get each of those things as an outcome. And so you'll see here we specify how many outcomes we want, and then inside of each outcome, there's a list of possible outcomes. So the reason why it's like this is that basically it does a roll. You could call it like a dice roll inside of each of these possible outcomes. Actually, we're going to do 2 possible outcomes. That's going to be much simpler. So we're going to have 2 possible outcomes, and in the first possible outcome, there's 2 different types of items that you can get, and then in the second possible outcome, there's a 100% chance of getting a certain item. So we'll do, so you'll see there's this weight, and that specifies, the percentage chance, the percentage weight of this outcome happening. So the higher the weight, the more likely that this outcome will happen. So we're going to give this a chance. So let's do, there's going to be 80% chance of the first outcome, 20% chance second outcome. And you'll see here we have all these different outcomes that you can select. And all of these are changing a certain entity. So like we talked before, entities represent, basically the building blocks of your games. They're an object in your game. And so they can be an item. So in this example, we're gonna create them as an item. So you'll see we're gonna select the receive entity quantity, and that's gonna basically increase the quantity of our entity. And since it's an item, that's basically how an item functions, is that the quantity of an item grows as you collect more of it. So we're gonna select the receive entity quantity outcome, and this entity is gonna have an entity ID, which is EID of we'll call it item gold. Let's call it item gold. I think that works. And then this item gold is going to have a group ID of item. So group ID is just a way to, group certain entities together. So this entity group will be called the item entity group. It could also be, if we were creating another group, it could be like the buff group or the stat group, or a character group. So it could be many different things, ways to group entities together. But for this example, we're going to group them in items. So we have this item gold, it's in the group of items, and then we'll give it a quantity. So let's say you get 100 gold when you get this outcome. And you'll see here there's this WID, and that stands for World ID. And we're not going to use it for the purposes of this, but basically that's a really cool feature that allows you to change the entities of another world. So like how we mentioned before, how like if you wanted to do a race in Plethora and get gold in Cubetopia, you could do this by basically specifying in the WID the world ID of Cubetopia. And then as long as Cubetopia has given you permission to change their entity, their gold entity, then you'll be able to, basically when this outcome happens, it'll give you gold in the Cubetopia world. But for the sake of this, we're not gonna use that because that's gonna overcomplicate this, and we wanna basically only change your user data in your own world. So this other 20% chance outcome, let's say you receive a different item. Let's say you get gems. So we'll get an item of gem, and we'll specify that you get 50 gems. So there's an 80% chance of getting 100 gold. There's a 20% chance of getting 50 gems. And then you'll see we also have this other possible outcome. So the reason for this is that let's say you want to get more than one entity in an outcome. So you'll see here like you'll get either gold or gems, but let's say you want every time you also want to get experience. So we're going to give this a 100% chance, and we're going to give the player, let's call it XP. So item XP, so item, and we're going to get, I don't know, 500 XP every time that we do a quest. So now you'll see that we receive 80% chance of gold, 20% of a gem, and then we always get experience points, 100% chance of getting experience points when we do a quest. Awesome. So hopefully that all makes sense up until now. We basically specified a quest, given it a time constraint. You can do this quest once every minute. It has two outcomes. You either get gold or gems, and you get experience points. And then down below, the last thing that we could also configure if we wanted is this action plugin. So action plugin is basically, they're basically custom bits of code that you can write to do custom functionality. And you can see here that we have a few custom action plugins already written. And so we've already written these to provide functionality that most games will want, and things like verifying ICP payments, ICRC payments, and verifying that a player has burned an NFT before allowing them to do an action. So like, for example, if we wanted to allow them to only do a quest once they've transferred, 0.1 ICP to our wallet, then, that's basically what this is for. You can essentially specify that they must, validate, they must do this additional action or additional validation on top of the validation that the action already does. So like, for instance, another example is if you wanted to make sure that they burned an NFT before being able to do this action, you can specify the canister ID that you want them to burn the NFT from before being able to do this action. So yep, that's kind of an overview of plugins. There's also, like claiming staking rewards and things like that also are additional plugins. But for now, we're not going to use it, so just to not overcomplicate things. And actually, I'm going to go back and I'm going to dive a little bit more into entity constraints. We're not using them for this, but I kind of want to talk a bit about, the different parameters involved in entity constraints. So you'll see we have this group ID again. So let's kind of fill this out, and I'll give you guys an example. Let's say in order to do this quest, you must have at least 20,000 experience before being able to do this quest. So the way you would do that is you specify an entity constraint, and we'll specify the group ID as item, the entity ID was the one that we created already, item XP, so experience points. And the world ID, we're just gonna go ahead and specify our own world ID because we're not using. You can actually create an entity constraint that checks another world to make sure that you have enough of the item in another world before being able to do this action. But we're gonna only be checking our world, so we're gonna just use our own world ID. Um, and and then you can specify what value you want to check. So you can check that the experience points are greater than or equal to, let's say, 5,000, right? So if you check that the experience points are greater than or equal to 5,000, that means that you must have at least 5,000 of this item XP in order to do this action. And you can also do something else. You can do like equal to attribute. So that means that that's a different feature of entities. And so each entity has an attribute. So you can even check that this entity has a certain attribute tied to it. You can check that the entity has less than a certain quantity of an item. You can also check that the entity is not expired. And basically, expiration of entities is a feature related to buffs. So, you know, basically any entity can have an expiration date. And once that expiration date has been reached, then the entity will be expired. And so that's something that you can also check to see if like the entity is still valid and not expired yet. But for the purposes of this, we're not going to use an entity constraint because it doesn't make sense for this case. But that's basically all the different things that go into creating an action config. So we'll go ahead. I think we're good on this, and we'll go ahead and create it. Awesome. So we got the all good. And now if we scroll back down here and we go to get action configs, you'll see now, and the one cool trick is you can click on UI here to be able to view the query response in a much more readable format. You can also click on JSON, but JSON is still kind of hard to read. So UI is the best one, I think. And you'll see here we have our quest that we created and all the values that we specified for that quest action. Awesome. So we've created our first action. Now a way you can test it is basically by going down to the process action function. So we talked about this a bit earlier. This is a way for a player to take an action in your game. And we can actually directly call this this function from here. And you can see you can specify like if there's custom arguments for an action. Like if you're transferring ICP, for instance, for this action, then you could specify the block index of the transaction that you sent the ICP. Or if you're burning an NFT, you specify the index of the NFT that you burnt, things like that. But for this example, we're not using any action plugins, so there's no custom logic going on. So we're just going to use the default action. So we specify the quest 01 action ID, since that's the one that we created up here as the action ID, and we can go ahead and call it. And what this will do will return us the outcomes of doing this action. So we see here we got 100 gold and we got 500 XP. Awesome. So it worked, right? So now we did this action. If we do it again, you'll see that every time we call this, we're going to get a successful response. But that doesn't necessarily mean that everything on the back end was correctly done. And the reason for this is that on the world, it does something called client-side prediction. And so it's returning to you basically what it predicts to be valid. But in reality, there's one more canister call that it does to the database, where the database validates whether the player can actually do this action or not, like whether or not they actually have enough gold or enough time between this action and the last action to be able to actually do it. And so if we go to our get all user world entities, and this will fetch all the entities that belong to this user in this world, you'll see that we actually only got 100, even though we called this action twice, we still only got 100 gold and 500 experience points. And the reason why is because we set the time constraint of this action to be a minute, and then we called this action twice within the span of 10 seconds. And so for that reason, the second time that we did it, it was an invalid action, and so it didn't give us, gold and experience again. So it only gave us the gold and experience for the first time. And so that's an example of how client-side prediction can basically make update calls much faster. And so that way, even though we have a fully scalable database that is across thousands and thousands of canisters, it only takes one update call to do a request and a response for an action. And so that way, it's super fast. And that's something that we took into consideration when building out the design of our world engine. So now that we've kind of tried out one action, maybe we can also specify an entity config. We created these different entities as we saw before. We created this gold entity, this item gem entity, this item XP entity. But in your game, you're not going to show the player that they got item underscore gem, right? Or item underscore gold. You're actually going to show the actual name of that item, an image along with that item, and any other metadata that might pertain to that item. And so if you want to add additional metadata to your entity, this is where you can specify that metadata. And so you can create essentially an entity config that adds additional metadata for a specific item. And so let's do it for gold, right? So we have this entity that's already called item gold. You see we specified it earlier, and it belongs to the group of item. Its tag. If we want to specify a tag, we can. We actually don't need to specify a tag. That's an optional value. And then, of course, you can specify a duration. That's also an optional value. Metadata, an object URL, a name, a description, an image URL, or a rarity. So these are all different things that you can specify about this entity. We'll give this entity a name, so we're going to call it like awesome gold, right? And we'll give a description like this is really cool gold. And then if you have an image that you want to display for this item, you can upload that image to a canister and then just specify the URL to that image here. We didn't do that, so I'm not gonna do that now. And also, like if this was like a character or something, it might have a rarity, and so you can specify the rarity here as well. So we're gonna go ahead and create this. Awesome. So we created our first entity config, and you'll see if we scroll down, we can get all our entity configs. Nice. And you'll see here we now have this item gold entity config. And so you'll see in our Unity template that when you load the game, it fetches all of your configs. So it fetches all your action configs and all your entity configs. And so you'll be able to access, basically all this metadata in your game to show the item in the game in a way that's readable to the player. And then you can also change all of this. You can change all of this config data, on the fly, and live operate your game as you want. So that's basically kind of an overview of entity configs. So we've basically created the two things that you can create in your world. You can create actions. Actually, you can create action configs, and you can create entity configs. And then when you do actions, you get entities saved to your user data. And the way to check that is you call get all user world entities is basically the way that you can check what entities that you have in your user data. And then you can also call get all user world actions to check the state of the actions that you've done. And so we've done this quest one time, and the last time we did it was at this timestamp. So this is basically the way for you to check, when's the last time you did this action. And then if you're on the client, you can, that way you can show to the player like, oh, you can't do this action for at least another 10 minutes or another hour or so, So this is basically the way to check the state of the current action that you're allowing the player to do. So I think that covers actually most of it. The permissions are pretty self-explanatory, so I won't dive too much into those yet. I think that's kind of like more advanced stuff, so maybe we'll do another video to cover those kind of things. And then unfortunately, when you have an action that you've already created, or an action config that you've already created, or an entity config that you've already created, in order to update those configs, you have to specify all the values again. And this is, we are aware of this. This is like a terrible experience because you don't want to have to, if you want to update an existing action, you don't have to specify all the fields again. So we're working on basically creating a candid UI that allows you to, query the current action configs and edit them directly, and then, push all of your updates, all of your edits directly back to the world. So, all right, let's configure some more complex actions and show you guys some more use cases for configuring actions. And I apologize if my voice is starting to sound a bit rough. I've been in calls all day, so I've been talking and my voice is like starting to give out. But yeah, let's create some more actions here. So right now we've only created a quest action, but you can actually create actions to span much more use cases than this. And so one example is if you want to create a crafting game, or a game where you're crafting certain items from other items, or you're crafting certain NFTs from other NFTs. You can create a crafting action. So let's go ahead and create a crafting action. We'll call it craft. We'll have the same time constraint. Actually, with crafting, we don't really need a time constraint because you can craft whenever you want, but there will be an entity constraint. So let's say in order to do this crafting, you have to have, let's say 100 gold, right? So, oh, this is the group ID. So this is going to be item. It's going to be item gold, and then the world ID is going to be our own world, and then greater than or equal quantity is going to be 100. All right, cool. So we have this entity constraint that requires that you must have at least 100 gold in order to do this crafting action. Some outcomes here. So we're going to have, if you do this crafting, you're going to have a 100% chance of getting, what should we get? A sword? Let's say you get a sword. So you get a sword item if you get one sword item for crafting this gold. Well, actually, okay, something I forgot. So you're not only receiving a sword, but you're also spending 100 gold, right? So this entity constraint just validates that you have 100 gold, but it doesn't actually spend 100 gold. And so there actually needs to be an outcome that spends the gold for you. So we're going to give a 100% chance of spend entity quantity, and that's going to spend our gold for us. So we're going to specify the item gold, the group ID is item, and the quantity is 100 gold. So that's going to spend 100 gold. And then the outcome of that, or another outcome of that, is that we'll receive a sword. So we'll specify this sword. It's also an item, and we're going to get one sword. So basically what this does is, when you spend 100 gold, it checks that you have 100 gold in your entity constraint. So it checks the entities that you have saved in your user data to make sure that you actually have 100 gold. And then it spends 100 gold, because that's one of the outcomes that was specified. And then you receive one sword in return. So that's a crafting action, right? You're spending 100 gold and you're getting one sword in return. And this is just a really simple crafting recipe, but you can create, much more complex crafting recipes, and you can actually throw in NFTs as well. So let's do an example of a crafting recipe that uses NFTs. So let's say you want to create a crafting action where the user is burning a certain number of NFTs and then minting an NFT as a result. So in order to do this, you first need to create an NFT collection. You can go to the Deploy NFTs tab on the game launcher, create a new NFT collection. You'll see here that I've already created a few, so I'm going to use one of the ones that I've created. And once you've created it, the first thing you should do is make your world canister an admin of your NFT collection. So copy your canister ID of your world, and then go to Admin Controller tab and click on this field here and add your world as an admin. This will allow your world to call your NFT collection canister to mint and burn NFTs. All right, so your admin has been added. Then go to the Configure Images tab, and you'll want to configure the different images that you want to use for your NFTs. So I'm going to be using a wood NFT and an iron NFT. When you upload an image, you specify an image asset ID. So I'm going to call this wood image 01. Awesome. Call this iron image 01. Awesome. So my asset IDs have been uploaded, and if I click on Get All Asset IDs of Collection, you'll see that I now have an iron image 01 and a wood image 01. And if you want to check your images, you can simply copy that asset ID, paste it into this field below, and then check the image here. Perfect. So now that we have our images, let's configure our actions. So we'll go back to the world. The first thing we need to do is create two actions, one for minting wood and one for minting iron. So let's do that first. So we'll do a mint wood action, and this action is simply going to have an outcome of 100% chance of minting a wood. Oh, actually, sorry, so the asset ID is the image that we uploaded just now. So it would be wood image 01. The metadata, we'll just specify the metadata of the NFT. You could think of almost as like an item ID. And so we're going to specify the metadata as wood because that specifies that this NFT is of type wood. And then the canister ID is the canister ID of the NFT collection. So we'll go ahead and copy that from here and paste that in. And you don't need to specify an index. The index will actually get assigned to this NFT when the minting happens. So that's why this is an optional field. You're not supposed to specify it. Let's go ahead and create that action. Awesome. And now we're going to do the same thing for iron as well. So we're going to change a few of these values here. Iron, it's going to be a metadata of iron, same canister ID. All of that looks good. We're going to go ahead and create our action here. And you see this action doesn't have any constraints, so you can call it as many times as you want. Obviously, in a real game, you wouldn't want players to be able to mint as many NFTs that they want. There'd be some sort of constraints to how often they can mint these NFTs. So that's everything that we need to create the minting action. Now that we've created the minting action, let's go ahead and create the crafting action. So now that you're able to mint iron and mint wood NFTs, let's create an action where you can craft wood and iron to mint a sword NFT. So let's call this one craft 02. It's going to have an action plugin of verify burn NFTs. And this is really important to note. There's different action plugins, and this action plugin verifies that the user is burning these NFTs before allowing them to do this action. And so you'll see here you have to specify the canister ID of the NFT collection again. So we'll go ahead and do that. And then this required NFT metadata field is really important. And it's basically an array of the different metadata of the NFTs that you are burning. So it's basically validating that the NFTs that the user is burning has this metadata. So like in our example, we want the user to burn, let's say, 1 wood and 2 iron NFTs to be able to do this action. So they're burning 1 wood and 2 irons to be able to get a sword NFT. And so by specifying the metadata of like one NFT has the metadata of wood, one NFT has the metadata of iron, and another NFT has the metadata of iron. And something else to note, if you don't care what the metadata of the NFTs being burnt are, you can actually leave these empty. So if I specified required NFT metadata of 3, but left these empty, that just means that you require 3 NFTs from this NFT collection to be burnt, but you don't care what metadata the NFTs had. So these fields are more if you want to specify certain types of NFTs inside of your NFT collection being burnt. That means that basically these 3 NFTs must be burnt and must have the specific NFT metadata in order for this action to be validated. So then if they do that successfully and they're not cheating, then the outcome of this action should be that they get a sword NFT. So we'll go ahead and create one outcome with 100% chance of happening, and it'll mint an NFT. Actually, we forgot to specify an asset ID of a sword, but I'll go ahead and just make one up. We'll call it sword image 01. And then the metadata of the sword will be sword. The canister ID is the same NFT canister as our wood and iron, and that's it. So now basically what this action does is it verifies that the user has burnt a wood NFT, an iron NFT, another iron NFT, and then as a result, they get a sword NFT minted. So that's basically the gist of creating a crafting action where the user is burning NFTs in order to craft and mint a new NFT. So we'll go ahead and create this action. All good. Awesome. So if we look at the action config that we've created, we'll see we have this mint wood, mint iron, and craft O2, which craft O2 basically is for minting a sword and burning a wood and 2 iron NFTs. And it's really important to note that the wood and iron NFTs have this wood and iron metadata, which corresponds to the required NFT metadata that this action requires in the NFTs that are being burnt in the verify burn NFTs action plugin. So these are basically checking that 3 NFTs were burnt, one with wood specified and 2 with iron specified in the metadata. So that's how that works. We can go ahead and call this action. Let's go to process action. First, we need to mint the wood and iron NFTs. So we can do this simply by calling the mint wood and mint iron action. And the way I'm going to have us verify that it works, first we're going to go back to the NFT collection and then click on Get Token Registry to be able to see what NFTs have been minted so far. And you'll see if we click on this, there hasn't been any NFTs minted so far. So we're going to go ahead and mint a wood NFT by specifying the default because it's not using an action plugin and the mint wood action ID. And this will mint us 1 wood NFT. Awesome. So that's a good result. And you'll see if we go back to our NFT token registry and fetch it again, we should see that it's minted us 1 NFT. Awesome. And so this is the NFT index. You'll see that it's 0 because this is the first NFT ever minted in this collection. And then this is the address of the holder of the NFT, which is my user. Sweet, so I minted a wood, and now I'm going to mint 2 iron NFTs because we need 1 wood and 2 iron to mint a sword NFT. So we called it once, let's call it again to get 2 iron. Perfect. So now if we go back, we'll see that there should be 3 NFTs now. Perfect. There's now 3 NFTs, 1 wood, and 2 iron. Awesome. And you can even double check an NFT's data by just copying the index and simply putting it in the token index here. And then you'll be able to view an NFT's data. And you'll see here the metadata of 0 is wood, and it has this wood image. How awesome is that? Cool. So now that we've created, now that we've minted our wood and iron NFTs, we can now call our crafting action. But first, we need to specify the verify burn NFTs action plugin. That's when you're calling an action that's using an action plugin, you need to specify the correct action plugin here because it'll require special arguments. So this requires an array of indexes of the NFTs that we are burning and then the action ID. So the action ID is craft O2, and then we're going to be burning, we go back here, we're going to be burning 0, 1, and 2, 1 wood and 2 iron to be able to do this crafting action. So we'll do 0, 1, and 2. That's going to burn NFTs on indexes 0, 1, and 2. It's going to check that their NFT metadata corresponds to 1 wood and 2 iron. And if it validates that correctly, then it'll allow you to mint a sword NFT as a result. So if we go ahead and call this, it should allow us to mint a sword NFT. We've got the OK, and you'll see here it's saying that we minted a sword. We'll double check on our NFT collection. Awesome. So now there's this 3rd NFT that we minted, and you'll see here the first 3 NFTs have all been burnt. So they've been sent to the burn address, and we've minted this sword NFT as a result. And so if we'll copy this over into viewing the NFT metadata, you'll see that we now have a sword NFT. How awesome is that? Sweet. So that's just a quick tutorial of where you burn a few NFTs, check their metadata, and then mint NFTs as a reward or as a result of this crafting action. And this can be expanded to many, many use cases. You can have many, many NFTs being burnt, many, many NFTs being minted. And so you can create hundreds of different crafting recipes for all the different NFTs and items in your game basically anything in your game can be represented as an NFT. And so that's a really powerful way to leverage the World Engine to be able to build a game that's fully on chain and also has everything in the game be an NFT if you wish. So we can dive a little bit more into some of the other specific use cases that actions can be used for. I've already given examples for doing a quest or crafting, but really any action in a game can be represented. And so we'll see here when you specify an action outcome, there's a bunch of different outcomes. And so let's just quickly go over some of them, and maybe that'll help give insight into the many different actions that can be done. So you'll see that we've done minting an NFT, but you can also mint a token as well. So that could be an ICRC token that you have for your game. So a player could do an action like, doing a quest or fighting an enemy and then receive tokens in return. You can have actions for spending entity quantity and receiving entity quantity. We kind of talked about that already, but that's basically if you're treating like an entity like an item and it has a quantity, so you can have the item quantity be decremented or incremented depending on what you're doing, if you're transacting the item or you're receiving the item as a reward. Another use case of this is for stats. So if you have stats in your game where you're tracking user stats, like how often they're doing a certain action in a game, that can also be tracked using quantities as well. And then we have the set entity attribute, which is basically every entity has an entity attribute, and that is basically a text field that can be set to anything that you want. And something to note, once you've set an entity attribute, you can then check it in the entity constraint, so you can ensure that a player has an entity with a certain attribute before allowing them to do an action. And finally, there's entity expiration. So every entity also has an expiration time, or can have an expiration time. It doesn't need to have one though. And basically what this enables are features like buffs. So things like buffs need an expiration because you can only have a buff for a certain amount of time. And so for these time limited buffs, you can have, let's say you have a buff that makes you 2 times faster in your game for 5 minutes, right? Something like that. Basically, to start the buff, you would have an outcome of renew entity expiration, and basically that creates an expiration timestamp for the buff. So like if we select that, you'll see you can basically select a duration for the buff. So and this is in nanoseconds, so it could be like 1 minute. Let's do whatever 1 minute in nanoseconds is as a duration. So that would basically give you 1 minute of this. We can call this like a buff GID, and entity ID would be something like buff speed, right? So that gives you 2 times speed for 1 minute. And so what's cool about this too is that if you already have the buff speed and you get another buff speed, it actually adds to the current buff that you have. So then, like, let's say I had 30 seconds left on the current buff and another buff gets added, and now I have 1 minute and 30 seconds, right? So that's one really cool feature of the renew entity expiration, is that it's basically a buff system built in. And of course, reduce entity expiration is the exact opposite. Like if you have a buff and you want to reduce it, then that's what this action or this outcome does, is it reduces the expiration time of the buff by a certain duration. So basically with these different outcomes, you can essentially create almost any different type of data that you need in a game. Everything in a game can essentially be represented as an entity. And if you want to dig more into how an entity is structured, I recommend digging into our tech documentation, which you can find on Gitbook. And that basically breaks down, the structure and the fields of an entity, and that'll give you more of an insight into all these different fields and how you can structure them to build basically any entity that you need. So that kind of covers, most of the situations that you would use an action. And of course, if you have additional questions, please reach out to me on the BOOM DAO Discord in the Game Devs channel, and I'm happy to answer them. And now we're going to move on to the game launcher and the Unity template, which are also critical products that BOOM DAO has built to help game developers on the IC. So this is the game launcher, and you'll see there's games that are showcased here. As a game developer, you can upload your game, and basically when you do this, you can drag and drop your game build files, and this is your game client. So if you're using Unity, you can do a WebGL build, an Android build, a PC build. And if you're uploading a WebGL game, then it'll immediately be playable directly from the canister that it's uploaded to. If you're uploading an Android or PC build, then the player will click on the canister and it'll open a web page where they can download those game files and install them on their devices. And then you'll see that there's also tabs for deploying NFTs and deploying tokens. So when you deploy an NFT, you literally just specify the name and the description. And this is a NFT collection I already deployed. You can change the admins and controllers. So all this stuff is self-custodial. So it's fully, controlled by you. So you can remove and add controllers and admins as you please. And then the images are configurable here. And you'll see there's this tab for minting NFTs. And so you can specify how many NFTs you want to mint, the image asset ID, if there's any metadata associated with the image. We tend to use JSON for the metadata, but it's up to you what you want to use for that. And then you can specify a comma-separated list of principals or addresses, and it'll mint to all of those principals or addresses, however many NFTs that you specified. And you'll see also there's this optional field called NFT burn timestamp. And basically when we were building Plethora, we realized that sometimes you want to create NFTs that are a limited edition NFT, right? It's or a limited time NFT. So after a certain time, the NFT gets burnt. So it encourages the player to use their NFT in your game, as soon as possible. And so that's a way to encourage engagement in your game. And so you can specify a timestamp in milliseconds, and that will the NFT will automatically burn when it reaches that timestamp. And then there's also the ability to airdrop NFTs to the holders of another NFT collection. So you can specify, the canister ID of the Pokebox collection, and the other data like we mentioned before, and then it'll mint an NFT to each holder in the Pokebox collection. So that's a good way to do user acquisition. So if you want to, get a bunch of the holders of another NFT collection to come play in your game, then you can use the airdrop feature. And of course, you can also burn an NFT as well. And if you want to burn or mint an NFT from in-game, we'll kind of go over those steps in a little bit. But this is just a way. If you want to test, burning an NFT, you can do it from here as well. And then finally, there's this tab for deploying tokens, and these are ICRC tokens. And so if you create a new token, you specify the token name, token symbol, the total supply of the tokens, how many decimal places this token will have. I believe Bitcoin has 8, so that's kind of the standard. The token description, token logo, and then how much the transaction fee when the token's being used. And you'll notice there's this use precision value in parentheses. And basically what that means is that when you specify, the token transaction fee, you're not going to specify like 0.001. In reality, depending on however many decimal places there are, you're going to specify, 10 to the amount of decimal places. So if there's 8 decimal places, then that means that one, like let's say for Bitcoin, there's 8 decimal places. So 1 Bitcoin is actually in precision value, it'd be 8 with 8 following zeros, if that makes sense. So you're going to specify the precision value of the token transaction fee. So normally that's something like 10, maybe 100, which would be the equivalent of like 0.001 or something like that. So yeah, that's just something to clarify, and it's a standard that's used for ICP, for ICRC tokens, and it's something that Definity, Ethereum, and Bitcoin have all kind of adopted for their internal way of doing things. So that's basically an overview of all this. If you have questions on any of this, feel free to join our Boom DAO Discord and ask any questions in the Game Devs channel. I'm going to be there, always answering any questions, as well as our team. So anything that might be confusing about this, please reach out to us in that channel. So I'll also now dive a little bit into the Unity template. So the Unity template is essentially, the template that we created so that you don't have to worry about figuring out how to connect Unity or how to make Unity be able to call canisters on the internet computer. So you can see if you just go we've deployed, a version of the Unity template to a canister, so you can literally just go there and try it out. And you can see you have ICP, you have ICRC test tokens, and you have NFTs. And you can get any of these for free just by going to get test tokens, and you can mint free NFTs or free ICRC just by clicking on it. And then it'll mint those for you, and you'll be able to test the game with them. So let's show a little bit about what you can do here. You have basically in this template, there's a bunch of different examples of features that every Web3 game needs. So there's a shop, and this shop allows you to spend ICP to get items. It allows you to spend ICRC tokens to get items. It allows you to trade one item in the game for another item in the game, and it allows you to buy NFTs with ICP. So this is kind of example code for everything that you need in an in-game shop. And then there's also NFT marketplace, and this marketplace and all of our NFTs are using the EXTv2 standard, since that's the most widely adopted standard in the IC ecosystem. We're definitely open to integrating other standards in the future, but that's the one that's being used the most currently. And you'll see that you can make a listing with any NFTs that you own, or you can purchase NFTs of other players. So that's the marketplace. There's also examples for staking. So we have staking ICP, staking ICRC, staking NFTs. You'll see there's also this button for claiming staking rewards. So every 24 hours or however long you set, you'll be able to claim rewards for staking the tokens or NFTs that you stake. And then you have here the functionality for burning an NFT. So in a game, usually when you burn an NFT, it means that you're using an item, right? So like if you can imagine, like in a game, an NFT could be like a ticket or like a resource that you're using to craft, another item. And so you burn one NFT and maybe you get a different NFT as a result. And so we wanted to essentially mimic that functionality and give you an example of that. So with this, you essentially can burn one of your NFTs. So I have 26 NFTs right now. I'll go ahead and burn one, and it'll give me a random character. So it'll give me one of these random characters. I got character D, sweet. So that's all using basically a loot box system on the back end, and we're gonna talk a little bit more about that in a little bit. It's basically using the world engine to run all of these different functionalities here. And something important to note is that this Unity template is made entirely possible by a complex C# agent library written by a core member of BOOM DAO. It also unlocks native and secure login with internet identity and NFID on all platforms and devices, which has never been possible before. This library, now dubbed the ICP.NET library, allows the Unity game engine to sign and authenticate calls directly to the internet computer canisters. Feel free to head to the BOOM DAO GitHub and download the Unity template today to get started. So thank you so much for watching, and hopefully I'll come out with another video soon if there's additional questions that need to be clarified.